My name is Kyle Swanson, and I'm a full professor in the Atmospheric Science group, and we're located in the Department of Mathematical Sciences here at UWM. The field of climate dynamics is a very broad field within atmospheric science. My particular areas of interest are really in the energy flows of the climate system. So how does energy come into and go out of the Earth, for example, on sort of the large scale, and then on smaller scales, how does energy flow into and out of things like Lake Michigan. Locally, I do have some interest in more local problems. For example, a very important element of tourism in Wisconsin, sort of winter recreational activities, and if you go back to comparing the 1970s to now, there's certainly a lot less snow during the winter, and this impacts this particular business enormously. If temperatures are going to warm globally a lot, the impacts on Wisconsin are going to be significantly larger than they would be, obviously, if temperatures remain the same as they are now. The sort of holy grail of what I would like to understand would be how the energy budget of the planet is going to change due to climate change. And at least recently this has included trying to understand how clouds and water vapor in the Earth's atmosphere are going to be changing in response to climate change. Over the past years or so, the surface temperature of Lake Michigan has jumped by something on the order of 4 or 5 degrees Celsius, which is a very significant jump, and this increases the amount of water that gets evaporated off the surface of the lake. Why is Lake Michigan warmed? It turns out that the answer appears to be that we've had anomalous levels of clear sky for whatever reason in the sort of early spring months when the lake is warming, and that's what's led to this temperature jump. I do view climate change as being a very important issue. I view global warming as something that's inevitable and it's going to happen over the 21st century. My overall goal is to try to come up with a observationally based, verifiable estimate of what that temperature change is going to be.